All right, let's go harder. Let's do the derivative of f of x, where we have in 3x plus 1 in parentheses to the fourth power times 4x minus 3 in parentheses to the fifth power. So I took a second and I wrote it where I showed what I was taking the derivative of here. So we take the derivative of the first, leaving the second one alone, because this is a product rule. And then we add the first one times the derivative of the second. Each of these require a chain rule. So for the 3x plus 1 to the fourth power, I let u equal 3x plus 1. So I had u to the fourth, and we take the derivative of that. That's like an f of u there. So that's like my f prime of u. And then the derivative of u equals 3x plus 1 is du dx equals 3. We put these together, and I got 4u cubed times 3. That was the derivative with the chain rule. And I left the 4x minus 3 to the fifth power alone for now. And then I went ahead and went over to the other side and did the other side. So we're taking the derivative of 4x minus 3, all of that to the fifth power. We're going to make, I chose a different letter just so there was no confusion. I went with w. So I said w equals 4x minus 3. The derivative of w with respect to x is dw x, which is 4. And that makes my main function I'm dealing with there. This is like my f of w here. So this is like f prime of w. And I'm putting those together. So 5w to the fourth times 4, and then we're times the 3x plus 1 to the fourth we already had. Okay? And then I just cleaned it up. I multiplied the 4 and the 3 together. I replaced u with 3x plus 1 to the fourth. Here I multiplied the 4 and the 5 together. That's 20. I left the w to the fourth at the end so that they would both be in the same order. And this is what we get. And you can leave it like that. There's no real need to clean that up anymore. Okay. Here's another example for you to try. Oh, I have that too high. You can see too much already. That's a bad deal. This was a quotient rule. Do y equals 3x squared over the quantity 1 minus 2x, all that cubed. All right, I'll assume you pause the video and we'll take a look at it. So we have low d high minus high d low over low squared. High is 3x squared, so the derivative of high is 6x. This is a quotient rule. Then low is 1 minus 2x cubed. This is going to require a chain rule to find the derivative of the low. So I said 1 minus 2x equals u. And that made low equal u cubed. And so d low is the derivative of u cubed, which is 3u squared, times du dx, and du dx was a negative 2 when we take the derivative. So I clean that up, and my d low here is negative 6 times 1 minus 2x squared. Having those, I plugged everything in here. I've got low d high minus high d low all over low squared. 1 minus 2x cubed, that's squared. Remember when we have exponents like that, we're multiplying them to get the 6. And what I did on the next step, there is 1 minus 2x's all over the place. So there's 1 minus 2x with that set, there's 1 minus 2x with this set, and there's 1 minus 2x on bottom. It looks like this is the one that has the lowest exponent. So what I did is I factored that out. I factored out 1 minus 2x to the second power. And I factored it out on top and bottom. And this is how you should do it. You shouldn't cancel, like cross things off in the middle like that. Don't be lazy. Quit being lazy like that. It's terrible. Because if you mess up, you're getting a lot wrong. And if you mess up with the way I did it, I'll at least know where you messed up, that you weren't like just not knowing how to do it. You just made a mistake. The other benefit of factoring out the 1 minus 2x squared here first is you can always multiply it back in to make sure you get what you started with before. If I do, oh, oops, I wanted not on the marker. There we go. If I multiply this times this, I get the cube back. And if I multiply it over here, it just shows up all together. And I still have the minus 3x squared minus 6, that's there. And I have the 6x right there. Everything looks good. So I'm going to undo some of that underlining right there. And then what I did is I grabbed these two. And this is where I canceled. And those equal a 1 when you cancel them. So that just left this part right here. And on the next line, I distributed. So I did 6x times 1 is 6x. 6x times negative 2x is negative 12x. And then negative 3x squared times negative 6 is plus 18x squared. I added them together. The x squareds combine. I get 6x plus 6x squared on top. You can check to see if it simplifies. And the way you would do it is you can factor out both a 6 and x on top. If you do, you have 6x times 1 plus x on top, 1 minus 2x to the 4th power on bottom, and nothing cancels. So you could stop it either way with the 6x plus 6x squared or in the factored form. All right. So, upgrade. What if we have something inside another something inside another something? This is like function inception. I have h of x inside of g, which is inside of f. So if I do the box analogy like I did earlier, I start on the outside, take the derivative of f. So this was the outside one. And then once I've taken care of the outside one, I move inward. I've got the middle one here. That's my middle. And I took the derivative there, and then I go in again, and I got the inner one here. That does not look like the word middle. There we go. So another way of looking at it is I wrote them the other way, and here I use W, V, and U, where U is on the inside. Sometimes, and quite often, it's easiest to identify what's on the inside and start replacing it and working outward till you can see what you have. And I want to change the notation there. I want to say dw dx here. And w, this is the way I've got it written here, k equals w. If I ignore what's on the inside, k equals w. So I'm taking the derivative with respect to x. Notice if I did the fraction thing, those cancel, and I'm still with dw over dx. Again, this is not a fraction thing, but it does help me see what I'm doing. So if I do my inner function needs the dx. My middle function needs to be with respect to the previous variable, the inside one. And my outer one needs to be with respect to the middle one. Okay? So you're just, again, you're either working outward, going inward, which when you have practice and you're skilled at it, that's what you'll do. But until then, it's often easiest to start identifying stuff that's on the middle. So let's say f of x equals sine cubed of 2x to the 4th minus 1. And we want to find the derivative of this. So if I were to say there's an inner function here, it looks like 2x to the fourth minus 1 is the inner function. So I'm going to say u equals 2x to the fourth minus 1, and that'll give me a sine cubed u. And if I find du dx, I have 8x cubed. Sine cubed u is sine u, and then all of that cubed. So it looks like sine u is my middle function here. And I used v up above to represent my middle, so that's what I did here. I said middle was v equals sine u, and I needed a dv du, and that gives me cosine u du dx. But now I've got, like, this is all equal to v cubed, and v cubed is like my outer letter w. So I need to take the derivative with respect to that one, the respect to the previous letter. So dw with respect to the previous letter is with respect to v. So w was v cubed. I wrote it in a weird order here, but if I take the derivative with respect to v, I've got dw dv equals 3v squared times dv du. And dw dv is my f prime of x, because this is effectively what we're working. Oh, wait, yeah. I was just showing that subpart there. Sorry, dw dv is that. So f prime of x is going to be 3v squared times dv du. And then I replaced my v squared with sine u, my v with sine u, so I had sine squared u. I replaced dv du with my cosine u du dx. And now I got u's in both, but that's not where I want. I want to go all the way back up here to u equals 2x to the fourth power minus 1. So I'm replacing u with 2x to the fourth minus 1. And my du dx, I calculated as 8x cubed. And so to put it all together, I moved the 8x cubed to the front with the 3 to get the 24x cubed. And then I had my two trig functions. If I were to do this on my own, the way I would do it is I would start off rewriting f of x like this. I would write sine of 2x to the fourth minus 1 cubed, like that. And then when I'm doing f prime of x, I'm working on the outside, working in. I bring the 3 down, lower the power by 1, and that gets me that. And then I do times the derivative of the inside. The derivative of the inside of this times the derivative of that would be times cosine of 2x to the fourth minus 1. I'll do like this. That's my inside there. Then I got another inner one. So I multiply it times the derivative of that, which is 8x cubed. So I keep working from the outside inward until I don't have any more inner parentheses. And you'll notice this looks like this without all the extra steps. But until you're comfortable doing that, and that's gonna be a while, especially for something like this, I suggest you write out the steps like I had over on the left. All right, one more video,